Well, good morning, everybody. In my video today, I'm going to try to stitch together several of the ideas that we've been compiling for the last several weeks. So here's my plan. I want to talk to you about drought. I'm going to talk to you about soil moisture change, and then I'm going to go right into the long-range forecasts. I want to look at what's been driving the pattern up into this point, and then we're going to try to explain how, if those same features continued into the future, what it might look like. So that's what we're going to spend a lot of these tabs on. I'm then going to come back to the near-term forecast, which involves the breaking down of the big western ridge, what it means to see the return of flow going across the northern tier of the United States, and see what the precipitation pattern is going to be as a result of that as we work our way toward mid-June. At the very end of this, I'm going to stretch it out and again show you the European weeklies and their projections from mid-June to mid-July. And my last two slides here will be a quick international update. So that's where we're going. You've been looking here at a map of drought, and the drought monitor right now is currently showing about 12% of the lower 48 in drought. It made another slight decrease in total area in the last update. And just thinking about where drought currently sits, we've had a lot of discussion about what's been going on in Mexico and its influence down here in parts of the southwestern United States. We've talked about how the drought in Kansas continues to be something that, despite rain trying to move through Kansas, bringing in some relief, it's not been enough to wipe out the drought. And even though we're expecting a lot more wet weather for southern Florida, these last couple of months have been extremely dry overall, and that continues to be a problem. All right. If we just think, though, about when was the last time we saw this low of drought area, I'm going to show you a time series of drought going back to the inception of the modern drought monitor, which was in 2000. And if you just take a look, here we are now at about 12% drought area. You have to go all the way back to like spring of 2020 before you find that low of drought area across the country. So this has been a 4-year-long process of getting us back to a lower drought total number. Now, thinking through that, I want to give you a couple of just kind of perspective on the spring. And we've looked at these maps a lot, but let's just do it again. Basically, from the beginning of April through the 6th of June, these are precipitation ranks by climate district. And one of the reasons why we keep coming back to this is to remind you that when all of these new long-range weather forecast models were initialized, they were all initialized with wet conditions in a corridor here, with drier to their west and drier to the very far southeast. In fact, just to put a point on how dry Florida has been, we can see here we're looking at like a top 3, 4, 5 driest April and May time periods on record. But just keep this in mind, because you're going to see something like that showing up in these longer term models. We only have one in right now. We'll get the National Multi-Model Ensemble in over the weekend. We'll look at it, of course, on Monday. But I wanted to add one more perspective to this, and that was to show you the departure from normal. So now these numbers aren't ranks, they're actual inches averaged over a climate district. So just to understand, to get to be 6 inches above normal across such a broad area, that means we have locally some places that are 10, 12 inches above normal. And down here in this part of Texas, that whole district is 14.44. But as you know, there are places there that after repeated storms have rolled through this region, including a lot this week, that we have spots here that are probably 20 plus inches above their historical averages. And I'm talking again just about April, May through the first 6 days of June. So, all right, looking at all of that and adding, some additional perspective on it, I want to take a look at soil moisture. Back on April 1st, this is what our soil moisture map looked like. And long-standing drought in parts of Kansas coming out of Oklahoma and Texas. We saw this was still the reflection of last autumn's drought throughout the Mississippi, Ohio, and this part of the Missouri Valley. And since then, just the absolutely chaotic severe weather outbreaks, incredibly heavy rain, it's done this. Now remember, when the model was initialized, all of this was wet again. So just stuff that into the back of our heads as we get into this longer range discussion here in a few moments. Just in the last 7 days alone, this is what our total accumulated precipitation looks like. And it was leading up until the last just couple of days with the same pattern that we've been in for so long. It's broken right now. It has changed. There's a large ridge in the west, which has prompted the excessive heat watches and warnings for Arizona and California, but there's quite a bit of heat farther to the north in this as well. But this is just what the last 7 days has done to deliver precipitation. And I could spend hours kind of picking out all of the individual spots and what they've seen. But in these videos, the idea is to get this bigger picture of what's going on. All right, I did want to show one thing though, and that was that the National Weather Service out of Lubbock did do an article on June 2nd. So we talked a bit about that earlier this week about the storms that were in the Panhandle. And one of the things I want to show you as we kind of slide down here through their analysis is that we had some very, very large hail that came out of this. You may have heard about it in the news or seen it on social media, but I'm only going to post this here because the National Weather Service has got permission to show this. But there it is. That is possibly, I think it is the new record holder for hailstone size in the state of Texas. And this was found, all the credit goes to Val Castor. I don't know this person, but that's who the picture was courtesy of to get to the National Weather Service. So I appreciate him giving permission for them to show it. And it's on their .gov site, so I'd like to show it to you as well. That is a monstrous hailstone, and just wanted to make sure that you knew something like that fell out of the sky just this past week. All right, thinking this all through, just in the last 24 hours, we watched the system exit. It did actually produce some tornado damage over in the mid-Atlantic and some locally very heavy rains just here in the last 24 hours. But as I think about all of this, questions that keep just floating in my head are what's been driving it and does it continue? So we're going to do this again. Where have we been? Where are we going? What about the longer range? And how speculative is it? So this map, as we transition into the longer range discussion here, shows us the upper level trough ridge pattern throughout the month of May. And this comes from the ERA 5 data set, which is, we think, our best historical record of weather information using reanalysis type procedures. And what it shows us is we have had two large areas of high pressure sitting here and here. The flow has been very fast to the north of it, and this has forced it to kind of dive into the western United States and roll around this trough and eject. We've had a sizable ridge that's lived over Mexico in this time period, and the Bermuda High, which is not, it's supposed to be here, has been split kind of into two pieces, one that is there and one that goes over to northern Europe, which you can see in this region. It's actually been the same pattern with this ridge causing flow to come down like this and roll out into a trough that's been over this part of Russia that's made from the Black Sea, and east of it. I'm talking about this particular corridor, so dry as of late as well. So we're just kind of stitching together this whole northern hemisphere pattern to understand if it's going to break away from this, what it might mean. One of the things that we have to consider here is that a lot of times we just want to attribute the pattern to all one thing, but it's almost always a combination of a dozen different things. And what would be unique for us to just look at here today and just try to study is this PDO signal, Pacific Decadal Oscillation signal, is the strongest. We talked about it. We've been looking at it for months. But the interesting thing is the ridge that's over Mexico, or the split in the Bermuda High at this point. And that ridge over Mexico has been substantial. Just looking at a 2-month drought indicator here, this comes from a data set called CHIRPS. I showed you earlier in the week the wildfires that were in Mexico and the wildfire smoke, but this really just kind of helps us understand that May was likely the driest May on record in Mexico. When the new ERA 5 stats come in, I'll be sure and show them to you. In fact, I think they are already in, but I haven't downloaded the data just yet. But it's just to point out how dry things have been there. And that's been a very interesting consequence of this pattern. Okay, the other part of this is what the MJO has been up to. And if we look across the tropics, we have seen at times good rising motion in this part of the Indian Ocean, over Indonesia, and even out here into the open Pacific. But the big thing here has been a lot of subsidence in Central America. And as summer approaches and we start to see summer-like features showing up in the jet stream pattern or in the movement of things in the tropics, we need to ask, is this going to continue? Because in the near term, the lid has been taken off of this area after it's been on for weeks upon weeks. All right, so here's the big idea. I'm going to just break down a few different pieces of the flow, and we're going to look at the Atlantic and the Pacific, and we're also going to look at the equatorial Pacific as 3 different areas. The Atlantic's coming up. We're going to start first with that same topic we covered yesterday, the Pacific Decadal Oscillation. Now remember, as we kind of zoomed in here on the end of this, the PDO in May has gone very negative, and that's what's promoted those big ridges that you saw. Now, if we just make some assumptions here and say, all right, what if we spend the remainder of summer with a very negative PDO? Like what does that mean? Because in May, the historical correlations from 1940 to 2022 with the geopotential height, that's the trough ridge pattern, has suggested that there would be large ridges here, and possibly over parts of Mexico, and maybe, just maybe, some sort of a split in the Bermuda High. So I look at all of that and go, all right, that narrative carries. It's not exactly the same thing that we have had. For example, the split in the Bermuda High has sent the high pressure much farther to the north here and way over to here, and the ridge in Mexico is a bit farther to the south. But there's a major PDO flavor to this pattern, and if it's going to dominate things, how much control is it going to have on the position of our temperature and precipitation patterns during summer? Because it certainly influenced things in May, as we've been discussing. Okay, so again, PDO, what are we looking for here? Well, it's really a discussion about pressure patterns across the North Pacific, but it's often reflected in an ocean temperature pattern where we tended to have very warm ocean here and cooler waters across the west coast of North America. Interestingly enough, normally when the PDO is like it currently is negative, we tend to have more of a La Nina signal, which we don't quite have, and the Atlantic historically was a bit cooler here. So that's one thing that maybe is working against the PDO. So I don't know, if we maybe say, well, the PDO's got 70% of the pattern. I'm just making that number, but let's just say it's controlling 7/10 of the pattern. And La Nina down here is maybe 1.5, and then the Atlantic is maybe 1.5. That's maybe the way to think about it. If you're looking at all 10 parts, I'm going to attribute most of it to the PDO signal. So thinking about that, we just have to say, all right, let's say that the PDO signal continues. Now I want to be very clear here. You're going to look at some correlation maps, but I've adjusted the color bar so that it is going to be intuitive to the upcoming summer forecast. All right. So remember, we have a negative PDO. So what I wanted to see was what would the resulting summer temperature patterns be? So I have flipped this, right? So that you could see that generally means warmer than average conditions central United States. We tend to have a lot of heat, tends to anchor somewhere in the central United States, maybe, as you can see here, kind of bullseyeing down toward Texas. Now, that would just be what history says. And if we say that 7/10 of this pattern is driven by the PDO going into summer, that's a lot of Central Plains, parts of the Western Corn Belt, getting into the Southwest. That's a lot of heat in the midsection of the country. All right, what about the precipitation? Now, again, I've altered the color bar so that this makes sense. We also tend to see that would be where our lowest precipitation rates are going to be. And as you note here, the model is kind of suggesting that historically, based on these correlations, we tend to anchor drier conditions into that spot first. Now, it doesn't mean it can't storm. It just doesn't. And also remember, we are anticipating an active hurricane season that could easily wipe this out with a system in July or August and, of course, in September and October. But just take note, it's just not through here. It extends back into the Western Plains. It extends into the Western Corn Belt. In fact, it extends into the Ohio Valley and also into the Eastern Great Lakes. That's what PDO and its contribution to this would look like. So how big of a signal is the PDO? It's pretty strong right now. As we take note, underneath that high pressure, we have very warm ocean temperatures and cool water that lines the coast. And I've made a story now for you for months that watching this water change these temperatures is critical to understanding the upcoming summer pattern. But what's interesting, though, is that we've got this very weak signal here of like La Nina trying to show up. And you know that from my last several videos, I've not even talked about it much, right? I keep saying it's a background feature. It is not, if it's going to be a player, it'll be late in fall. It'll be into this upcoming winter. It is not just playing second fiddle. It's like the kid that's almost kicked out of the band because of how dominant these two players are, the North Pacific and North Atlantic. So we're going to come back to this in a few moments, but I'm going to talk to you about the North Atlantic. How warm it is in this region is going to be critical to seeing this pattern evolve. So right in through this area here, it's based off of wind, pressure, and the ocean temperatures. We have this feature called the Atlantic meridional mode. Now, you've heard me talk about the Pacific meridional mode, which does link up with the PDO. That's the cooler water that's sitting in this area. But the question is how warm this is. How is this going to influence several factors? So let's go look at it. The current state of the Atlantic meridional mode, if you look at these distributions, in May, we're looking at 3 standard deviations above the mean. So, this is out there. It's very much positive. So you say, well, historically, what does that tend to do? So again, I have looked at I've altered the colors on the color bar so that you would see the blues, or these cooler colors in through here, as wet. And what we've seen historically is that some of these years extend this wetness throughout a big section here of the middle part of North America, from basically the Mississippi Valley, the whole of it. And so the ocean temperature pattern in the Atlantic is actually pushing against the ocean temperature pattern in the Pacific and the resulting pressure patterns. Again, the PDO against the AMM. Now, we have to add in the third kid, right? The one that's almost getting kicked out of the band, and that is this guy here. We've watched the ocean temperatures out in the middle of the Pacific drop back down to neutral. And there's big questions. Does this just stay neutral, or do we go into stronger, indicators toward La Nina, or what? Where is this going to end up going? But I want to show you, if we end up getting more of a La Nina flavor, again, June through August, this is the area that tends to be drier. And if we stack all that up, understanding that this might be the smallest player of the 3 that I'm going to present to you, it at least has a complementary mode to the PDO signal right now. That's what we're trying to think through this. So what do we do with all of this? Well, I'm trying to just let you know what has really shaped the upcoming forecast from these models. And I'm going to put together maybe my own story with it. This is what the previous forecast from the European model said that we should expect out of those central Pacific Ocean temperatures along the equator, where El Nino La Nina happens. The May forecast was coming way down here with the ensemble average. But as you can see, the dots here indicate where it has been, and so the May forecast was too aggressive, and that's why the new June forecast is not as aggressive. And if we just take this out, honestly, the European model is ENSO neutral all the way through the beginning of winter. That's what we could say. Now, there's possibilities that it gets down here into weak La Nina, but there's also forecast runs that take it up here on the positive side. The spread's large. The spread's very large. We look at the ensemble average, it's somewhere here, very weak negative, and so that's a weak La Nina. So all of that is to inform you as to why the new June, July, August forecast looks like this. I think it's all competing. And I think the biggest issue with the model telling us that this is what June, July, and August is going to look like is because of when it was run initially, this is where the soil moisture was. It was in that corridor. And soil moisture is one of the important indicators going into any forecast model as to where the longer range might go. And it had drought in Mexico, and it was drier here. Remember, we looked at those statistics just a few moments ago. It was right at the very beginning. It's this. Do you notice how the model has attempted to kind of keep that around? Now, it made some changes. For example, it started to bring more drier air in here. Why? I think that's the PDO signal working its way in. I think we have the AMM signal trying to keep this area wetter. And I think we have the soil moisture signals in here also keeping it wetter. But that's fine. That is what it is, but what does it all mean? To be honest with you, it doesn't mean anything. And all of these subseasonal factors could at any moment come in and take over the pattern. What I am kind of building an idea for you about, though, is I'm most concerned about this PDO signal and what it did in May. That's why we've been talking about it for the last couple of weeks and watching those ocean temperatures. So I'm going to make this case. If we continue to see this pattern, in other words, if this does not change, here's that same narrative. If these waters do not change in temperature, remember, the waters are reacting. The surface water temperature is reacting to the atmospheric pattern. If we don't see change in this, then our heat and potential dry risks going into summer tend to be more in the central and southern plains. And if that's the case, we end up getting a lot of ridge riding storms that come over the top of this through the Canadian prairie. through parts of the Corn Belt, into the Mid-South, into the East Coast, while we start to worry about the heat that builds into the Central Plains and the drought that would follow as a result. And then what will be kind of chaotic with the whole pattern is the fact that we could follow this up with surges of moisture, some of them coming from the tropical systems, or maybe the AMM flexing its muscles in the middle of the summer. If these waters warm, you take all of this and shove it to the west, and that anchors it over the southwestern United States. That's why I kept bringing up 2020, because that's what happened. In 2020, this warm water filled all of this in. And it didn't matter that La Nina was coming. It filled it all in with the Atlantic so warm. And that's why all of the heat and drought slid over to here, and the storms just cascaded over the top of that. That's why we keep coming back to that particular year. But this is where this all kind of sits and hangs in the balance. And to be honest, I don't have a tremendous amount of confidence in any long-range forecast. But I needed you to see what was all going into this. So with that as a backdrop, now that we've covered the updates on the longer range, let's get back into what we're dealing with now. And the jet stream right now is already beginning its breakdown. Momentum is increasing out here in the North Pacific. The large ridge that's been along the West Coast, we know that that's got an expiration date. It's not going to last around too much longer. And we do need to watch this trough that's coming over the Baja here and what it could potentially do to set up a stormy setup in the in the middle part of the United States. Our all hazards weather map early this morning here. Had to record a bit earlier than normal today. 5:20 a.m. Central Time. This is where all the heat is. We talked extensively about this. And as we look out there later today, let's see if they've done an update on this. No. So we look at here later today, and it's going to be Nebraska, Kansas that has the greatest risk of some strong to severe storms. Getting into the day tomorrow on the 8th, this would be Saturday. Again, we're going to watch that stalled out, boundary sitting in there, a little bit drier air to the north. And we're going to see where the precip comes through. And this would be the day on Sunday. So let's start off with where we are early this morning here with the radar. So just seeing here one system leave, some showers coming across southern Canadian prairies, still some storms early this morning that were in parts of the plains. But was the model halfway well initialized? Kind of. It really isn't a perfect setup. But as we go forward, take a look at what's coming in with this flow right here. And if I get back to it right there, here, you can see that once we work our way throughout the day on Friday into Friday evening, we have the scattered storms in this area with the risk of the strong to severe storms. They do get into the western Corn Belt here. The low that's leaving Ontario and Quebec, scattered precipitation and storms throughout the western mountains just on the heat that's here right now. As we play this forward into tonight and getting into early Saturday morning, we're going to watch what's left of that precip try to make its way into this section of the Midwest and moving over to the Ohio River Valley. Now, here we are on Saturday night, and again, we're watching for storms back here in the plains. There's a frontal boundary stretching through here. Rain moving, it looks like, through lower Michigan and also along the Ohio River Valley, according to the NAM. And we get this out into overnight hours on Saturday into early Sunday morning. And again, more storms could come out of Kansas into parts of Missouri and Illinois. Big picture, though, over the next 7 days, there's that stormier corridor that you saw, but there is a bit of a stretch of drier weather that could be in this area. Remember, it's drier, not dry. We're also going to talk about some stuff going on in the tropics here in a few minutes as well, because in the week 2, take a look at the surge of moisture coming out of the tropics here, and also the kind of realignment with the more active pattern across the northern tier of the U.S. into the Canadian prairie. So that's your new week 2 update from the European model. We'll take a look at it again, comparing it to the CPC and GFS in a moment. But all of this is being driven by the fact that that large ridge that's in the west has got its last couple of days, and it's going to start to fade. And we now see the forecast going back to a negative PNA. Just barely, but a negative PNA. That means no big west coast ridges are forecast to last. So thinking about that, let's go see it. Top-down view. As we play this forward, getting into this weekend and early next week, Monday, Tuesday, can you see it? That's strong zonal flow coming through the country, broader troughs north, some ridging in the southwest. This is just going to set things up for being active again across the lower 48. As we get out there toward the 14th, 15th, 16th, again, what do? We see a big buildup of heat, but a broader trough coming in the northwest. And this has been echoed not just here in the artificial intelligence, but it's also in the ensemble as well. As I get us out there toward the middle, really this is the third week of the month, I'll tell you, if we end up getting this could really set up the central U.S. for quite a bit of severe weather. And take a look at that guy right there. There have been several indications in several of the models that some sort of tropical feature is going to try to sneak out of the Caribbean and move to the north. We have no confidence in this right now. It's just showing up as an artifact in the models, but we can't ignore it because of what's going on in the tropics, which I'll show you again in a few moments. So given all of that, here's the next 7 days according to the artificial intelligence forecast. And again, the AI system has been much wetter here than any other forecast. Take a look. 7-day AI forecast. Here's the national blend of models. You notice it's not got that same feature there. It's wetter farther to the south, wetter back into the southern plains, really wet here. So that's 7 days from the NBM. Here's 7 days out from the WPC. Very similar forecast. Take a look at your individual region here. If we compare models, this would be the ECMWF forecast and the GFS. Very different forecasts right now. So they're struggling with the adjustment in the pattern. So if you want to see how different they are, take a look at this. This is a 7-day forecast where I take the ECMWF and subtract from it the GFS. So you've seen this many times, but these colors mean the GFS is warmer. These mean that the Euro is warmer. Wetter, forgive me, wetter. So the GFS has got this really wet set of corridors in through here and right there. European model is much wetter in these key areas surrounding it. What a difference these models have right now, especially with whatever the heck is coming out of the tropics. I mean, in some places here, the GFS is like 6 inches wetter in Florida than the European is, and they're both actually wet in Florida. So just to think about that. All right, so we got to compare them. And so I have on the left the European model, and on the right, I'm getting backwards today. On the left, I have the GFS. On the right, I have the European. And we've already seen through Sunday. There's our boundary. There's the low. There's a little system sneaking across the Canadian prairie. Right there, see it? And already by just Tuesday, the models have separated in their forecast. And you can see the GFS putting something through the Ohio Valley. Nothing here on the European. We then go into early next week. And if there's one thing they both agree on is that something's coming out of the tropics. The GFS lines it up on this front. The European takes the front way out here, sweeps it around, and then starts to bring this surge of moisture into the Gulf of Mexico. Very different forecasts. What's interesting, though, is that by next Friday, they start to sing the same song again. High pressure in through this area, see it? And some sort of front here. So I don't like how far apart they are at times, but they try to come back together about a week from now. So the reality of this is that this pattern is not settled even in the near term as we transition away from the big ridge that's in the west now. And the models are doing a pretty terrible job at agreeing with one another over what's going to happen in this upcoming forecast. So I'm just going to take you to some probability maps and just see if these add some clarity. This is our chance of getting an inch of total rainfall in the next 7 days. And if there is some sort of agreement, I think it's here. This part of Oklahoma, Kansas, Missouri, and then something coming out of the tropics there. And then we're going to regain, as I add more time to this, that's out to 10, 11 days, we regain more instability in the atmosphere, the return of moisture here, and a more active northern tier pattern, which is going to result in more precip. What's interesting about this is this hole right here, Illinois, Indiana, and Ohio, parts of Michigan, even extending over to Pennsylvania. And if we look on the drier side of this, I don't think a new runs in just started to trickle in. Sorry about that. If we look at the drier side of this, over the next 10 days, we see coming out of Montana drier. We see western Texas, New Mexico, and the southwest drier. And we see this corridor right in through here, drier as well. All right, from here, next bit of this story would be week 2. And during week 2, we do have some agreement in the models overall, right? The return of the active northern tier of the U.S. Canadian prairie storm track, something coming out of the tropics, maybe a drier stretch in between. This all makes sense based on what we just talked about. But from there, I just want to remind you that because the MJO is moved around a bit, taking the lid off of this part of the world, we're starting to see just indications in the models of something tropical emerging. And this is just the European model's solution for it. Why is that? That's where our best vertical motion is right now. It's sitting right on top of that area. So let's just watch the tropics carefully over the next 10 to 15 days. Temperature-wise, our frost map has very little gray on it because of how mild it is right now. And here's what today's high temperatures are expected to be. So this is Friday's highs. Again, another very hot one here in the southwest coming up to the Central Valley. Cooler around the Great Lakes. There's Saturday getting into Sunday. So a couple of interesting artifacts this morning from the National Digital Forecast database, but we get the overall gist of what's going on here. Very hot in southern Texas. This is Monday into Tuesday of next week, getting out there to Wednesday and Thursday. And remember, this is when we're starting to see that ridge begin to open up a bit more in the middle part of the country. And you can see that in the day 5 through 10. A lot of warmth coming into this area, but also a lot of instability. So that's a breakdown. That is a breakdown of the big western ridge. It opens up into the middle part of the country here. And if we look out there at day 10 through 15, getting us well into the middle of and past the middle of June. Very warm throughout the Great Lakes states and warm back into parts of the central United States as well and the east. So does the European model agree with it? Let's just get you started there at day 5 through 10 and stretch it out. And the overall consensus is that it does. So putting this all together, let's finish this up with one last thing. We are transitioning towards summer. And this is just the one way to think about this. Take a look at this 10-day forecast of the jet stream level winds. Where winter is developing, the jet stream level winds are cranked. That's in the southern hemisphere. Where summer is developing, the jet stream level winds are backing off. And why this longer range forecast is so nuanced and difficult to predict is because when you lose the temperature contrast from the equator to the pole, that's what summer is. We just lose one of our most dominant forecasting things, which would be the jet stream pattern. And when you lose it, it shifts north and no longer becomes a dominant factor. It's all about where the moisture moves. And that's why we considered the PDO for how it moves moisture, how it moves temperature. That's why we consider La Nina. That's why we consider the Atlantic. And so we're at that time period now where summer predictability drops off dramatically because the winds do. We love it when there's strong kinematic forcing in the atmosphere just to tell us, hey, this front's going to come through or rising motion is going to be dramatically increased here and not here. But that's what we're about to lose. So as we look out there, we now have this. Can we put together what I talked about at the beginning now with a model forecast that's just looking out from mid-June to mid-July? The European model has given us this look now for several runs. This is the newest. Look, here's the same time period from the previous run, the run before that. Here's the run before that. And we can just keep going back in time, and they all kind of have this similar flavor. So this was 4 runs ago. Here's the latest run. And overall, we see this. And as we've been showing many times, we just watch as we go from this temperature pattern to the end of June and getting into the month of July with a lot of heat in the system anchoring right there. And what do we say? We would say that looks like the negative PDO signal working its way into the month of July. And that's why we think there could be a lot of heat in this area. It'll storm in this area, and it will likely storm all along the periphery of that area as well. And what we were trying to understand is how does the current soil moisture really influence this? But I think it's going to get hot. It's been a very strong signal, very, very strong signal in this area that that's going to be the case. And I'm basing almost all of that on this, that guy right there. All right, some international stuff as we finish this very long video. It is also extremely hot right now in the Russian wheat belt. This has been an ongoing story all week long. Take a look at how warm it is down here in parts of South America as well. Precipitation-wise, I've seen the models do this many times. It's like, oh no, bring storms in there. But every time it's been forecasting that, they've failed to manifest themselves on a larger scale to break this drought that's going on in this region. And so take it for what it is, but just understand that while I expect much of Europe to be stormy, this will be a critical area to continue to watch to see if we can actually bring rain into that region. We looked at the NDVI values earlier this week, which were very low. We looked at the last 60 days of moisture anomalies, which coming out of Ukraine into this part of Russia were very low as well. And that just continues to be the narrative in that region going forward. Other spots real quick, take a look south of the Yangtze, back very, very wet again. Indonesia, very wet again, extremely dry. It's been very hot throughout much of India, but take a look at how dry it is in this area right now. We're well ahead of the monsoon. And just to come back to one thing, I got to watch the tropics carefully now and then eventually Africa as we go forward. That's it. That's what I know. And it's going to change this upcoming weekend. You know it will. But I wanted to present to you my latest information, and I hope you have a great weekend. I'll talk to you next week. Thanks.